Hello everyone! In this video we're going to learn how to evaluate sigma notation. So first, here we have the Greek letter that represents sigma notation, which is always a summation notation that represents the sum of numbers. Here, the lower number represents the first value of k that we're going to replace here in the general term. And the upper number represents the last value of k that we will replace here. So here, k starts from 1 to 5. And of course, it goes up only by whole numbers. So like 1, 2, 3, up to 5. Now, to evaluate this sigma notation here, we start and replace the first value of k, which is 1. So here we replace k by 1. So we would have 1 plus 2. So here, when k is equal to 1. Plus now, we go up to the next whole number, which is 2. So we replace k by 2. So we will have 2 plus 2. So this is when k is equal to 2. Now replace k then by 3. So if we replace k by 3, we will have 3 plus 2, then 4 plus 2, and finally when k is equal to 5, we will get 5 plus 2. Now of course we cannot go on and replace k by 6 because it ends at 5. Now to simplify these numbers, we would have here 1 plus 2, which is equal to 3, then 2 plus 2, which is 4, then we have 5, up to 5 plus 2, which is 7. And if we add up all of these numbers, we will have 25. So as we see here, this sigma notation, or this summation, evaluates at 25. Or when we evaluate this sigma notation, the sum or the answer would be 25. Let's now go on to the next example. Here we have 4r plus 3, and the values of r start from 1 up to the last value, which is 30. So to evaluate this sigma here, as we did in the previous example, we will replace r by 1 first. Here we will have 4 times 1 plus 3. So 4 by 1 plus 3. Then now, the next term, we replace r by 2. We would have 4 times 2 here. So 4 by 2 plus 3. And next, we replace r by 3. So 4 by 3 plus 3. And so on here, up to the last term when r is equal to 30. So if we replace 30 here, we will have 4 times 30 plus 3. So 4 multiplied by 30 plus 3. Now, let's simplify here these numbers. First, here we have 4 plus 3, which is 7. Then 4 times 2 is 8, plus 3 would be 11. And here, this number would be 15, and so on. Now here, 4 multiplied by 30 would be 120. Then if we add 3, we have 123. Now here, as we see, we have lots of terms or numbers. And actually, we have 30 numbers added up together, because here r start from 1 to 30. And of course, it's hard to add up all of these numbers one by one. Instead, we add them up as an arithmetic series. So as we learned before in previous videos, these numbers represent an arithmetic series where the first term is 7 and the last term is 123. And actually here it's the 30th term, as we said. And to add up these, we can use this formula for the arithmetic series. This formula is given in the exam booklet. So here, n is equal to 30 since we have 30 numbers added together. So S30 is equal to, we replace here n divided by 2, so 30 divided by 2 times here the first term u1, which is 7, plus here un represent u30, which is the last term in the sequence, and in our example it's 123. And if we do this in the calculator, we would get 1950. So if we evaluate this sigma notation here, it will be 1950, which is the sum of all of these numbers.